Time t seconds, a particle has this velocity. It's moving in two dimensions. It's got an I component and a j component. We don't know whether it's on a flat table or what directions I and j are going in, but it doesn't matter. But the key thing is that this is variable acceleration, because v is not just dependent on time. It's actually dependent on t squared, which means acceleration will be dependent on time. So find the speed when t is 0. Let's find the velocity first of all, then we'll get the speed, which is the magnitude. So I'm going to write it in as a vector form, and I'm just going to get 7 minus 3. So then the speed will equal, we can apply Pythagoras' theorem, 7 squared plus minus 3 squared, square rooted. I'm applying Pythag because I'm going along, I'm actually going along 7 and down 3. And I want to know this length here. This is a right angle triangle. So that gives root 58, which is then 7.6157, which I rounded to three significant figures, 7.62 meters per second. You get away with not writing units in these maths questions, so to be honest, I tend to not, but I will here. Next up, the value of t when p is moving parallel to I plus j. So that's parallel to the vector 1, 1. And what that means is that the components must themselves be equal. This thing here must equal k, some value of k. But it doesn't matter. It just must be, therefore, that t squared minus 3t plus 7 is equal to t squared minus 3. What it means, we don't actually need to work out the value of k. It's going to be when we set them equal, and then we've got a quadratic to solve. So we can minus t squared from both sides, add 3t minus 7. This now equals 0. Factorize it. T plus 5, t minus 2 equals 0. So t is equal to minus 5, which I'm just going to reject because it's negative, or 2, which I'm not going to reject. That one is our answer. The acceleration of p at time t seconds. Well, this is the derivative dv by dt, the rate of change of velocity with respect to time, but it's the instantaneous change because this is varying. Yeah, it's not a constant variation for a. So I'm just going to again write it in vector form, 2t minus 3, and then just 4t. It doesn't say I have to write it in any particular form, so this should be absolutely fine. You could alternatively write it as 2t minus 3 in brackets I. By the way, I always underline my vectors because it just makes it clear, and that is the convention, especially when you have sort of scalar quantities going on as well. And then plus 4tj. And then the value of t when the direction of the acceleration is perpendicular to I. So we've got I going in this direction, and j, I mean, it might not be, but they're going to be perpendicular. That's the main thing. So if it's perpendicular to I, it means it's in the direction of j. So I need this to be non-zero, but most important thing is that 2t minus 3, the I component, is going to be equal to 0. I can just solve this. T is 3 over 2, or 1.5.